Hey, Algebra 2, good to see you. I'm in the same outfit as I was today when you saw me. But this is now Friday, so I promise I'm doing this on Thursday. So I did go home, and I hope you guys have a wonderful day, and I hope everything is awesome for you. You're gonna get a packet from the sub. It's a front back of notes. This is the new material. So please remember that there's going to be a quiz on Tuesday when you come back. That quiz was supposed to be taken today, but the notes that I'm giving you right now are not based on that. We will allow you to use your calculator on Tuesday. But I hope you guys and girls have a wonderful weekend. I hope it's restful. I hope you're able to enjoy your friends and your family, and remember, what's really important in life. But have a great time. But be awesome for the sub. And again, we're going to go through this. So take care of one another. Obviously, that's one of my things that I always like to tell you all. So take care of one another. You should have this packet now given to you by the sub. It's front back. And fill this out and take notes just like I would be teaching in class. Grab a Chromebook. Obviously, if you're hearing this, you obviously have a Chromebook. So if you have the Chromebook or you're using your phone to watch the video, awesome. Do what's perfect. I will tell you that if you borrow a Chromebook, would you please put it back in the Chrome cart and plug it back in so it charges? I appreciate that very much. And here we go. These are your notes. So now we're solving a system of linear equations. This is where we have one or more two lines or more lines that we're trying to figure out where they intersect each other. And there's different methods for doing this. And this is something you would have done in Algebra 1, but we're going to do this as well. And of course, on Wednesday, this assignment that will come off of this will be due on Wednesday next week. Tuesday next week, I will probably just collect your review that you've completed and that we went over today, and have some good study skills on that, and make sure you're feeling good. So I'm on the third slide now, moving down, and first thing that we're going to talk about is we are checking to see if it's a solution to the problem. So I have the point -3, -5. I need to check in both equations if it is a solution to the problem or not. So you know that this is a point, so that's an x and that is a y value. So plug it into both of your equations. So the first one, you have -3 minus -5. Is that equal to 8? Well, let's reduce our signs. -3 is +3. -5 is +5. And that's equal to 8. That gives me 8 equals 8. And that means that the point -3, 5 is on this line, guaranteed. Now let's see if it works on our other equation. So this other equation is right here. And we're going to plug our same x and y values, these x and y values, into this equation. And so I get 2 times -3 plus 5 times -5. And we want to know if that's equal to -31. And when we go ahead and do the math, so 2 times -3 is -6. 5 times -5 is -25. And so I have -6 minus 25. Is that equal to -31? Well, you'll realize if you do your arithmetic that -31, -31. That means that point exists on this line as well. So if these two lines had been graphed, they would actually have intersected at -3, -5. Okay, but we're just checking to see if that's the appropriate spot for them. When we are dealing with an inequality like these next ones, we just have to look for both of our statements to be true. Okay, so again, this is an x and a y value. We're going to plug those in and do the arithmetic. So 9 times -2 minus -8, that's minus, and is that indeed less than or equal to -10? So let's take a look. So 9 times -2 is -18, and -8 is +8. And so can we answer the question, is -10 less than or equal to? So we have the equal to. Well, that works, so we get a true statement on this first problem. On the second problem, we're going to take a look at it, and we're going to do the same exact thing. We're going to plug our x and y value in to our equation. So I have 2 times negative 2 minus negative 8. So minus negative 8. Is that greater than 52? So doing the arithmetic, let's see if it works. 2 times negative 2 is negative 4. Negative times negative is positive, so positive 8. Is that going to be bigger than 52? So is 4 greater than 52? Well, that's false. So if I had graphed these and shaded the appropriate regions, this particular point does not fall into the right parameter. It gives us a true on the first one, but not on the second one. So this is not a solution to this system of inequalities. So a few things to remember. If you're graphing these and you're using a straight edge is obviously something that has a straight edge on it. It doesn't have to be a ruler. We're identifying points. We're calculating the slope and the y-intercept from those 2 points. We're entering, we could enter the information into our calculator, and we identify the correlation. So right now, when we're looking at the correlation, remember we have the r and the r squared value. Well, we're just going to focus on the r right now, the one-dimensional, the linear dimension of it. And we want to understand what the slope and the 2 intercepts really represent. So this could come along on the Unit 2 quiz, which is what day? Tuesday. All right. If we take a look at this, we have y is equal to 2x plus 6, and then we have 3x plus 2y equals 2. So this is in slope-intercept form. This is in standard form. This is set up to do a substitution problem. And what our main goal is we're trying to figure out an x and a y value that works. So we're figuring out the point that these two intersect. If I was going to do this for substitution, I would know that my y value is equal to that, and I could take that and plug it into that y value right there. So I get 3x plus 2, and there used to be a y right there, and I'm going to plug something else in, and then I have negative 2. So this whole problem I rewrote with parentheses, and we have to realize, oh, this right here is going to plug in here, because that is what y is equal to. Let's go ahead and solve the problem. Don't forget how to distribute. So you get 3x plus 4x plus 12 is equal to negative 2. Combine your like terms, 7x plus 12 is equal to negative 2. Subtract 12 from both sides, so 7x is equal to negative 14. So we find that x is equal to negative 2. So we just found the x component of our answer. Now what we can do is we know that x is equal to this. We know x is equal to this value. Come on, go with the green. Equal to this. Well, I have an x here, and I have an x here. I choose whichever one works best. The top equation is already solved for us to find what y should be equal to. So I'm going to say, well, okay, well, y is equal to 2 times x plus 6. There had been an x here, but what am I going to plug in instead? Well, I know that x is equal to negative 2, so I'm going to plug that right in. Do the arithmetic. 2 times negative 2 is negative 4. We're going to add that to 6. And if I do that correctly, negative 4 added to 6 is 2. So our solution to this problem is negative 2 comma 2. It's a point. Okay, if I had graphed these two equations, these linear equations on a line, I would see that they would intersect at negative 2 comma 2. Sometimes graphing isn't the best way to do it because, let's face it, you might have it crossing at some fractional amount. It's kind of hard to see that. So substitution is a pretty good method. You might also remember something called the elimination method or the addition method. That's the same thing, and we'll see some of those in future slides. So substitution method, what we just did, solve one of the equations to isolate one of the variables. So pick one of the equations. One of them might be already set up. That last question was already set up saying y equals. But if it's not, we can manipulate one of them to get x or y equals. And then we're going to substitute that expression we just modified into the other equation. And then once we get the answer, we're going to substitute that letter, whether we solved for x or y, we're going to solve it back into one of the other equations, substitute it in, and then your answer will be a point. So ordered pair, okay, it's a point, x comma y. Okay, if you have parallel lines, they don't have a solution. So think about it. If you were to try and solve an equation that you had parallel lines, all of your x's and all of your y's are going to eventually come out, and you're going to get like a silly answer, something like 8 equals negative 10. And that's not the big mystery of life. You know that. This is nonsense. So this would amount to no solution taking place. And a lot of times we would call it the empty set. Okay? And the empty set just means that our solution doesn't exist on our graph. And think about it. If you have two parallel lines, will they ever cross? If no, then that means we're not going to have a solution. If we have two different slopes, even if it crosses way the heck off of our grid, we still have a solution. But if we have the same slopes, it's your lines are going to be parallel. And then you have the coincident lines, or infinitely many solutions. And this is kind of goofy. This means you've just graphed the same exact equation. So you would have one line, and then if you graph the other line, you would find the other line falls right on top of it, which is goofy, but this means we have infinite solutions to your problem. Infinite ordered pairs work to solve this problem. All right, this problem is set up really nicely for us to use the elimination method or the addition method. When you take a look at the two, you probably have realized that positive 7y and negative 7y are opposite values. So if I just go ahead and I add these two equations together just as they are, so you add 4x and 3x to get 7x, 7y minus 7y, those just canceled out, right? And then negative 10 added to negative 4 is negative 14. Solve this by dividing each side by 7. You'll find that x is equal to negative 2. Remember, we said your answer is going to be an ordered pair, a point. So I now know my x value is negative 2. Being I know that x is equal to negative 2, you can say, all right, well, should I plug it into this equation or this equation? It's your choice. The answer will be the same. I'm going to choose to plug it into the top one. So I'm going to get 4. There had been an x here, plus 7y is equal to negative 10. Okay, there had been an x here, but I know x is equal to negative 2, so I'm going to plug that in. Let's do our arithmetic. 4 times negative 2 is negative 8, plus 7y is equal to negative 10. Go back to Algebra 1 and say, oh, okay, well, I'm going to add 8 to both sides. And then you get 7y is equal to negative 2. And then 7 times y, undo it, so divide each side by 7. Those will cancel. And that's going to tell us that y is equal to negative 2 over 7. This is definitely a problem that you would not wanted to have graphed to find where they intersect. They truly do intersect, but let's face it, it's going to be kind of tough to figure out where negative 2/7 exists in the y direction. Okay, we can estimate it, but it's kind of hard to say, oh, it looks like negative 2/7. You'd have to have some really accurate graph paper to get something like that, which some people might have done, and this is something certainly from the past. The elimination method, it's also called the addition method. They mean the same thing, okay? You're just trying to figure out how to manipulate one or both of the equations to when you add them together, you have opposite either x values or y values or opposite variable, whatever your variable might be. And then once you solve for one of it, then you actually use substitution, the second step is substitution to get your answer out, all right? Let's look at this. They want us to use the elimination method. So we take a look at this first set of problems. And you're looking at it and going, well, I have a 2x and a positive 4x, so they're both positive. I have a negative 4y and a negative 5y. So if I add these together right now, I'd wind up with 6x minus 9y equals 21. That didn't help at all. So we might choose to say, you know what happens if I take this whole top equation and multiply it by negative 2? So I'm going to rewrite this top equation, bring it down here. So I have negative 4x, negative 2 times positive 4 is positive 8y, and then don't forget the last one, negative 2 times 13 is negative 26. I'm going to then move this equation just below it so I can subtract it. I know some of you are like, well, can't I just subtract it? Like, you sure can. I just wanted to show you the math behind it. If you do this, the x's are opposite, they cancel out. Combine your y's together, so positive 8y, subtracting 5y, that is 3y. And then if I subtract here, negative 26, subtracting 8 is negative 18. So you found that y is equal to negative 6. Once you know that y is equal to negative 6, you have one of your answers. Remember, it's a point. So you found the y value, so you're going to plug that y value in right down here. That's your y value. So remember, y equals negative 6. So then we have to take that back to the top. Should I plug that negative y value in here or here? It's your choice. It doesn't matter which one you choose. So I'm going to pick the top one. So I get 2x minus 4. I had a y originally, but now I don't. And it's still equal to 13. But the y value now, I'm going to plug the negative 6 in. So I'm going to take this. I'm going to plug it in right here. Watch your signs. So you get 2x. Negative 4 times negative 6 is positive 24. And that's equal to 13. If I subtract 24 from each side, you're going to realize that you should get an answer of 2x equals negative 11. And if 2x is equal to negative 11, you know that x is equal to negative 11 over 2. Reduce it if you can. If not, leave it as an improper fraction. And it looks just like that. We had another problem up there, didn't we? All right, let's try the same thing with this. This one we might choose to get rid of the y's. And what's sticking out to us right now is we have opposite y values. We have a positive and negative. Or looking at this top is negative to a positive. So you might want to choose to get rid of the y's first. You could choose to get rid of the x's. Just make sure that one of the numbers you multiply by is negative. But I'm going to choose to go ahead and get rid of the y values. So I'm going to have to multiply both equations by something. Opposite values could be negative 10 up here and positive 10 down here, which would mean I would multiply this whole top by 5 and this whole bottom by 2. So let's do that to the top equation. So I'm going to get 25x minus 10y is equal to negative 75, because 5 times negative 15. And then do the same thing with the bottom equation, but this time you're distributing the 2. So 2 times 7x is 14x. And then 2 times 5 is 10y. And that's going to be equal to, is that 36? And that, notice you now have opposite y values. So when you add these together, the y values will cancel out. And so I'm going to get 39x because 25 added to 14 is 39. And then if I subtract here, that looks like that should be, I believe, negative 39. Double check my work on that. Let's see. It's going to be negative, so that's going to be 6, 15, 9, and then that's a 6. Yep, perfect. So now we found that our x value is actually equal to negative 1. And you remember, we're solving this as an ordered pair, so let's bring that down here. We have an x and y value. And my x value I found to be negative 1. What do you think I do with that x value? Well, go back to your originals and you're going to plug it in. Okay? So I found I have negative 1. So for an x value, I can plug it into this first equation or the second equation. Again, it doesn't matter which one you pick. They're both going to come out the same. So I might pick the bottom equation to deal with that now. So I have 7. There was an x here. I'm going to plug something in. Plus 5y is equal to 18. I'm going to plug negative 1 in for my x. So I get negative 7 times negative 1 is negative 7. Add to 5y equals 18. And using Algebra 1, we're going to go ahead and move it on over. So let's see. I'm going to add 7 to both sides, so I'll wind up with 5y is equal to 7 added to 18 is 25. And then divide each side by 5. So 5 goes into 25 5 times. So this solution, if I had graphed these, would have crossed that negative 1 comma 5. And some of you might say, well, why didn't we just graph that originally? Well, if you take a look at your original problems, they're both set up to do the cover method, but the cover method on the top one, you'd have an x value of negative 3, a y value of 15 over 2, which is 7.5, and then on the bottom one, you're doing the cover method, you get your x value to equal 18 over 7, so that's not cool, and then y value would be 18 over 5. So just because our answer came out nice and easy doesn't mean, oh, if we just had done graphing, it would have been easier. That would have been kind of nasty. And you would have been really lucky if you would have gotten this as your intersection. You might have gotten close, but you couldn't guarantee it was the answer unless you truly did know it. This one says, tell how you could multiply through what to eliminate with a given system. So we're not really going to finish these problems. We're just going to go through and we're going to get them set up. And so we have to pick, do we all want to get rid of x or y? Well, I think on this first one, I might choose to get rid of the y first. So if I do that, that means that I could multiply the entire bottom equation by -3. So my top equation would be 4x minus 15y is equal to 8. Nothing happened to it because I didn't multiply anything. The bottom equation is -9x plus 15y equals -72. And then if I add those together, you would probably see that the y's would cancel out pretty nicely. But again, we just wanted to tell us how we'd go about this problem without solving it. This next problem, we have to choose to get rid of either x or y. This one I also might choose to get rid of y first. Okay. So by doing that, what's the smallest number that both 4 and 6 both go into evenly? And a lot of you would go to right away saying 24. You'd be right, you're going to get the answer, but you're just going to have bigger answers to work with. But if you recognized and saw, you know what, 12 works, you can multiply the whole top by 3 and the whole bottom by 2. And so if you showed what your top equation looks like, you'd get -21x plus 12y is equal to 90. And then the bottom equation is going to be 8x minus 12y is equal to 20. And again, if you added these together, you're going to see that the y values would cancel out nicely. But again, we didn't need to go through and do all of that. And then problem number 7 up here, again, we want to try and get rid of x or y. If you chose x, you're multiplying the whole top by 3 and the whole bottom by 11. You might not want to do that. It might be easier to say, you know what? Smallest number that both 3 and 8 go into is indeed 24. So you'd have to go through and you could multiply the whole top by 8 and the whole bottom by 3, and neither of them have to be negative when you multiply because you already have opposite values. So if you distributed 8, you get 88x plus 24y equals 8 times 124, whatever that comes out. This is a big number. I'm not using a calculator, so I'm just saying it's a big number for right now. And then 3 times 3 is 9x, and 3 times -8 is -24. Oops, I forgot the y right there. And then 3 times 13, I can do that one, it's 39. So again, if you had done this one, you had both your y values in there, please note that those would cancel out and you'd be able to start working the problem. Okay, crack your knuckles, have a good time. Everyone's doing fine? All right. How will parallel lines and no solution appear when using linear combination? Well, parallel lines, again, you would wind up with all of your x's and y's canceling out, and you would get something silly like -10 is equal to 4. So that's going to tell you you have no solution. It's part of the empty set. It doesn't exist. What about coincident lines and infinite many solutions? Once you work those out, all the x's and y's would fall out, and you'd wind up with like -6 is equal to -6, which is totally true, right? So you get one number equaling itself, and this means you would have infinite solutions if you were working them out. Remember that all the solutions are points, okay? Or you could have an empty set, or you could have infinite solutions. You need to check your solutions in both of the equations. If you don't do it in both, you're taking a chance that it works in one and not the other. And then when is substitution a good technique to use? The substitution is the better of the two techniques to use if it's easy to get y equals or x equals of one of the equations. If you have to really manipulate it, you start dealing with these big old fractions, that's not as fun. Yes, you could still do it, but you're dealing with big fractions. And so if x or y are easily solvable, please by all means use substitution. If they're not, go right to the elimination method. And normally the elimination method is set up in standard form. So remember that's ax plus by equals c. And then a, b, and c are not to be fractions when it's in standard form. When would it be better to use linear combination? If it's not easy, if it's hard to solve for a letter. So if you had, like negative 13x plus 22y equals 6, and then you had negative 10x minus 30y is equal to 12, that is not a nice substitution. It's not easy to get x or y all by itself, other than if you did, you'd have big fractions. You can predict the number of solutions without actually solving the system. So one solution means you just have different slopes. If you knew you had different slopes, you know the lines will cross once, and that will give you the one solution. No solution is if you're looking at it and you realize your slopes are parallel slopes. And then the infinitely many solutions is their parallel slopes. That's the first thing usually you would see. But then you'd say, well, wait a minute, it's the same line. The same line. So if you had, like, let's say you solved them both, and one was y equals 3/5 x plus 10, and another one, rather than having 3/5 x, you maybe double it, is y equals 6/10 x plus 9, I think I said. So if they're the same equation, then that's what's going to take place. All right. Frick and Frack pool their money to buy a new video game. I have no idea who Frick and Frack are. There's just two people that were in a video game system. Frick saved $6 more than twice the amount Frack saved. Oh my gosh. All right, so Frick, maybe we will call X. And Frack, we will call Y. Is that okay? And then I'm going to do two equations. So Frick and Frack want to pool their money together to buy this video game system. We know that Frick saved $6 more than twice the amount Frack saved, and then together they saved $348. So my first equation is going to be X plus Y. So what Frick has saved and what Frack has saved is 348. Okay? Now we have to figure out this other equation. Well, they tell us that Frick we called X, remember, saved 6 more than twice the amount that Frack, which was Y, saved, okay? So then we can say, all right, well, X, whatever he saved is equal to $6 more than twice what Frack has saved, okay? So Frick is our X value. He has $6 more than twice what Frack has. Well, this is set up now as substitution. So I could take this right here, and I could plug it in for X. So I'm going to get 6 plus 2y plus that y is equal to 348. Combine like terms, 6 plus 3y, because y and 2y is 3y, equals 348. Subtract the 6 from both sides, so we got 3y is equal to 342. And then divide each side by 3, so y is equal to 114. So this guy saved, so that's Frack, saved $114. Okay, that was our y value. Well, if we plug 114 in here, we're going to get x plus 114 equals 348. So you're really just going to say 348, subtracting the 114. The 8 from 4 is 4. That's just 3 there, and that's going to be a 2. So Frick has saved quite a bit more, $234. So I guess Frick gets to play the video game a lot more than Frack because he has more invested in it. And that's how you work that problem. 3 burritos and 2 drinks cost $11.35. Oh, I'm already hungry. I can go for a burrito right now. 5 burritos and 3 drinks cost $18.32. What is the cost of 1 burrito? All right, so 3 burritos, 3B, plus 2D for drinks is $11.35. Okay? And then 5 burritos, 5B, and 3 drinks, 3D, is equal to $18.32. If I was working this problem, I would get rid of the decimal. So I'd multiply each by 100. So I'm going to get 300b plus 200d is equal to 1135. And then I'm going to, again, multiply both by 100. So then I have 500b plus 300d is equal to 1832. And again, it's preference. Do you want to deal with the decimal or not? I'd say don't worry about the decimals and let's just start solving. So these are set up as elimination. So I think we could choose. Do we want to get rid of b or d first? And I probably would say, you know what? Let's get rid of d. So I'm going to multiply the whole top by 3 because that would give me a 600 there. I'll multiply the whole bottom by 2. And again, that's going to give me a 600. But we have to pick one of them to make one of them negative. It doesn't matter which one you make negative. So I'll make the bottom one negative. So if I do this, 3 times 300 is 900b plus 3 times 200 is 600d. And then 3 times that is going to be, let's see, 15, carry the 1, 9, 10, carry the 1, 3 times 3, that's 4, and 3, 4, 0, 5, that's a 600. And then the second equation, remember you're doing a negative, so be careful. Negative 200 times that is going to give me negative 1000b. Negative 2 times that is going to give me negative 600d. And then negative 2, that's going to be negative as well. So 2 times 2 is 4. 6. 2 times 8 is 16. Carry the 1. That's going to be 366. Our answer is going to come out negative, but watch this. Right here, does that give me a negative 100b? And then I'm going to get a negative answer here. So 3664. Subtracting 3405. It is a negative answer. I already have that down below. So I would have borrowed here to get 5. That's 14. That's 9. There's 5 here. And that's 2. So 259. So I get negative 259. If I divide both sides by negative 100, I wind up, remember your decimal, $2.59 is the cost of the burrito. So what is the cost of one burrito and one drink? Well, I have one burrito so far. So what do you think I should do with that burrito answer, that $2.59? Well, I'm going to take this $2.59 right here, and I'm going to plug that back into one of my original equations. Doesn't matter which one, I'll plug it in right there. So that's 3b plus 2d. Move that down. So 3b plus 2d equals 1135. So I'm going to plug the 259 in right here. Okay, that's the cost of the burrito, 259. Let's do the math. So 3 times 9 is 27, carry the 2. 3 times 5 is 15, and 2 is 17, decimal. Make sure you carry the 1. 3 times 2 is 6, 7, so I get 777 plus 2d equals 1135. Hopefully you have a calculator out because this would, don't do it like I'm doing it where I'm doing it longhand, but it doesn't hurt your mind if you're doing this. You just might make a grammatical error. I'm in the wrong class. 2d is equal to, I'd borrow here, so that'd be 15, that's an 8. I'm going to borrow from here, that is going to become a 10. So that's a 12. 12 minus 7, that's 5. 10 subtract that is a 3. And then if I divide both sides by 2, that's going to give me a 1 decimal 7 $1.79. So my drinks cost $1.79. Put a dollar sign. And your burrito is $2.59. And don't forget the dollar sign. Feeling good? Anyone hungry? I am. Oh boy, I could go for something. You know what I'm doing right now? I bet you I am looking at a cadaver. Yeah, buddy. Really, yeah. So, I know, made you chuckle. So how are we doing on these? I don't know how far we are. Oh, good. This is our last slide. Fantastic. So they just wanted us to work these out. So the first one appears pretty good. I would probably multiply this whole bottom equation by -2. Some of you might saw the y's right away, but the x's might work out. So that's going to give me -2x plus 10y is equal to -18. And to save space, I'm just going to combine those together. So the x's cancel. 3y and 10y is 13y equals -13. So I see that my y value has got to be -1. Remember, I'm going to take that -1, that y value, and plug it in either here or here. Doesn't matter. I'll pick it in the second one. 5 times -1 equals 9. And then I'm going to get x plus 5 equals 9. Subtract 5. So my first answer is this. Second problem set up pretty nicely. Maybe let's get rid of the x's. So I'm going to multiply the whole top equation by 2. That would give me a -4x and a +4x. And again, to save time, I'll just bring it down here. So that's going to give me -4x plus 2y is equal to 12. And if I add these two equations together, the x's cancel, the y's cancel, so I get 0 over here, and 0 is equal to 17. Well, that's nonsense. You know that 0 and 17 aren't the same number, so this means that you have no solution. It's part of the empty set, okay? These lines actually would have been parallel to each other. These would have crossed. These definitely would have crossed, but these are parallel, same slopes. And let's try this one. Let's get rid of, I'm going to multiply the whole top equation by 4, and that's going to allow us to get rid of the x's. I'll bring this down, so I get -4x plus 8y is equal to 12. If I add these two equations together, the x's are gone. I get 3y is equal to 9. So it looks like my y value on this one is equal to 3. So these definitely cross. I take my y value, plug it in either here or here. I'll take it out and put it on the top one. So -x plus 2 times 3, which is 6, is equal to 3. Subtract 6 from both sides, so I get -3. So x equals -3, comma 3. So these two lines would have crossed each other. That's one solution. And I bet you this last one's going to be an infinite solution. Let's get rid of the x's. I'm going to multiply this whole thing by 4. So I have -4x, because it was already negative, plus 8y is equal to 20. And if I add these two equations together, 4x's are gone. Oh, this isn't going to work out. So I get 14y is equal to 35. Yuck. And so I'm going to get my y value on here. I'm going to extend my page a little bit. My y value here is going to be 35 over 14. Oh my goodness. All right. So I'm going to take my 35/14ths, and yeah, I'm going to go for it. I'm going to take that y value and I'm going to plug it in. I'll plug it in right here. So I'm going to bring that top equation down. So I have -x plus 2 times 35 over 14. Remember, that was a y value, and then I'm just plugging it in, and then that's equal to 5. Oh, that'll be nice. So I get -x plus 35 over 7, because remember, up here, this will go into there 7 times, and that's going to be equal to 5. Okay, I'm going to add 35 over 7 to the other side, so -x is equal to, I'm going to convert 5 to 35. Is that going to work? Let's see. If I convert 5, put it over 1, 7, that's going to be 35 over 7. And then subtracting 35 over 7. And that's 0, so I get -x is equal to 0. And a lot of students get confused on that. Well, you know that x has to equal 0 then. Okay? So that right there is kind of your assignment. That's going to go along with the assignment. This assignment, we'll make it due on Wednesday. Tuesday, you know you have that quiz, right? So your worksheet, that will be due on Wednesday next week. The worksheet's going to be 3A. If you're looking at the top, it's going to be pages 47, page 47, 48, 49, and that's it. So things to know. That's due on Wednesday. Tuesday, we have the Unit 2 quiz. Okay? So make sure you're studying over the weekend for that, and then once you're done with the quiz, then you could probably focus on getting this done. You might be able to get a start on this early. It's not going to take away from what you already know. So guys and girls, I hope you have a super fantastic weekend. Again, take care of one another. I know I told you I'd tell you a story. I guess I'll have to owe you a story when I get back because this video is almost 41 minutes right now. So have a great day. Be kind to the sub. And also remember, if you borrowed one of the Chromebooks, put it back in the normal slot and plug it back in so it can charge, please. Thank you so much. Have a super awesome, great weekend. Guys and girls, I'm so proud of you. You guys are all also incredible. So enjoy.